Hey, hi everyone. In this video, we'll build AI agent using LangChain. In the last video, we built an AI agent from scratch, just using prompts. And in the last video, we built AI agent using function calling from OpenAI. Those two videos are very important to reach this video. So make sure you have watched it so that you fully understand what actually goes on under the hood in LangChain as well. It's very easy to just write the functions and get the agent working. But actually understanding what goes on so that if you encounter any issues ahead in your development, in your product development journey, you can actually go ahead and debug those properly. So it's very essential you understand all the steps there. But let's get started with LangChain in this video. So the first thing that we'll do is let's paste some import statements that we'll need. We'll be using Pydantic to define the schemas of our tools, and enum is just like we use enum for an input param in our tool. You'll see ahead like when we define the tools. We'll be building the exact same AI agent we built in the last tutorials, the e-commerce chatbot. So it will have access to 4 tools to search for a product and to make a purchase of the product. It can add to carts, and it can summarize carts as well. So you'll see all that, and after we import all these packages, we'll import another main package called tool from LangChain tools. So what this will essentially do is we can convert like any function to a tool now. Like in the last video, you saw like we had to give like OpenAI specifications of different tools that we have in a specific format, right? So we don't have to do that formatting ourselves now. LangChain will do that for us. I'll show you how. So say suppose this was one of our functions that we used. This is one of the tools, the search product tool, and you see like I've added a doc string here which explains what the function does. And now what we can do is we can just decorate this function with the tool from LangChain. So it will, this function will now convert to a tool basically. Once we do this, what we can do is we can import this utility function. It's called convert to OpenAI function. I'll use this and show you what exactly it does. So let's say we call this on search product. Since this is a tool now, it's an official OpenAI tool that we can use in our AI agents. We can actually get it converted to the format that OpenAI wants. Like this is the name of the tool. This is the description. These are the parameters. So product query, and product query is required. So if you see even here, if we do search product dot name, it gives us the name of the tool. And similarly, if you do search product dot description, it gives basically the doc string that is present here. So it gives like it saves it in the description. So this shows that this function has been converted to the tool, right? This is what the decorator does to this function. It converts it into a tool, and then we can use this other LangChain's utility function to actually convert it to a format where we can send this to OpenAI tools for function calling. Now one thing here is the properties. Regarding product query, you can see like there is no description about product query that is mentioned here. That is because we haven't given any description yet. So the way that we can define the structure of input that a tool takes is through Pydantic schema. So we'll create a class for defining product query, and the way we do it is by defining this class. Let's say we define this search product input class, and this inherits from base model that makes it like a Pydantic schema. And we only have one attribute here, which is product query, and we are saying that this is a string, and field is again like a Pydantic field. And here we define the description, saying the query string for product search. And now what we can do is, while defining this tool decorator, we can also pass in like arg schema, and we can pass in this class. So it knows that the input argument schema is defined by this class, this Pydantic schema class. So now when we run this, it will still have like search product name description. But when we now convert this to OpenAI function, it will have property as product query, but it will now have description as well. And you see the type is also string. So it picks up from the Pydantic schema about the input. So it says like, oh, product query is a string, and this is the description for the input parameter as well. So it creates this, this structure for OpenAI tools for us to pass in OpenAI. So you see, like, even till here, if you know this much, you can still go back to the last video, maybe use LangChain just to get the, the structure, and go ahead, like, build the complete thing just using this part of LangChain. Of course, we'll go ahead and use AgentExecutor as well in LangChain, but even till here, like, there can be like some parts in your project in which you use LangChain, and some parts you do it your own way. So this is also very helpful. Like, if you know all the possible ways how to build it, it becomes very useful. So let's go ahead and define all the remaining tools as well in this format. So after the search product, let's add the add to cart tool. Here there are like two inputs. So this is again a Pydantic schema. Product ID is a string, quantity is an integer. And then, like, this tool, basically we used it last time as well in last two tutorials. So you might know about this tool. And this is the description that we pass additionally. So this again, like, it will be decorated with tool, and we'll pass the arc schema here as well. And same way, let's define the remaining two tools. So after add to cart, I've added this summarize cart tool. It doesn't have any input. It just outputs the cart. And then so this is an enum now. For buy product, we define like the input schema as payment method, but this payment method is an enum. So this belongs to this payment method, and these are the possible values here. This is how you can define buy product. And this generate payment link, you might remember, like, it's just a util function, just to tell you, like, not every function is meant to be given to AI agent. Some functions can be util functions as well. So yeah, we have defined all this now. Basically, all our tools are ready. And we can convert all those tools to OpenAI functions now. So let's define tools as these four functions. These are like referring to the functions. So now that we have defined our tools, let's just import some modules from LangChain for us to be able to, make OpenAI calls. So this is just OpenAI. This is the prompt template, and this is a output parser that we are using. This is the functions agent output parser. You'll see like why we need it, basically to parse out the function calls and so on. So once this is imported, we are ready to start making OpenAI calls with these function formats, these tools that we have defined. The way to do it is first we'll convert these tools that we have to OpenAI format. So it will take this list of tools and it will convert to basically list of objects, the function definition that we did in the last video as well. So this will be like list of JSON, and each JSON containing something like this for each tool. You can also print this and see for yourself like how it has created the structure for each of these four tools that we have defined above. And then what we are doing is we are defining this model. It's a chat OpenAI model. I have exported my OpenAI keys when we did load env. And we are setting the model to 4.0. And now what we do is we bind this extra functions param, and we pass in this list of JSON. So in the last video, we actually passed it directly to the OpenAI API, but here we have to bind it since this is a LangChain function. Yeah, LangChain people still use functions and not tools. So that is one thing to remember. OpenAI has shifted to tools and deprecated functions. But in LangChain, this is how you pass in tools. That's fine. And then you define the prompt here. The system message can be something like you are an helpful assistant, or however you want to define it. And then user message can be the actual query message. And then we can create a chain out of this. So prompt will go to the model, and the output of the model will go to the OpenAI functions agent output parser. So this is a output parser. If you remember in last video, when we built like different LangChain projects, LangChain based chatbot as well, we used a different output parser. This is just to take out certain values from the model's output. We'll see how this is all working. So now that we have defined our chain, remember the chain has model, and model is bind binding the functions. So basically the model, we are saying like, hey, these are the tools, you can access these tools if you want based on user query. It's similar to the last video that where we saw function calling. So if OpenAI wants, it can trigger a tool, right? So let's input a query to this chain and see what happens. So I'm just putting like a very simple query which will definitely for sure use tools. So let's search for a blue handbag. Let's run this and see what happens. So it finished running. Let's look at result. Now the result is agent action message log, and it says like it wants to call the tool called search product with inputs blue handbag as product query. So this is what happened. Like if we run this without the output parser, I'll also show you without output parser. If we run this, what happens? And now if we print the result, here we get the AI message. This is the normal one, but here we get content as empty. And if you see here, like it says like function call, and it says like name and arguments and so on. This output parser, the OpenAI functions agent output parser, what it does is it sees these AI messages, sees if there is a function call, and converts it into this message log with tool and tool input. That's all what it does. Okay, so it's nothing fancy as such. You don't have to worry about it too much. Great. So now that we have gotten our response, we can also do something like result.tool, and we can also do something like result.tool input. So this prints out. So this is the exact values that we are interested in, which tool to call and with what input we want to call that tool with. Now, since we have wrapped search product within the tool decorator, what we can do is we can do something like this: search product.invoke. So invoke is a LangChain specific thing, which we can call because it's a tool now with result.tool input. And let's see what the observation is after running this. Let's print observation. Great. So you see 3 products were retrieved. It actually made the API call. It actually executed this tool, and we get this observation. This is what something that we can do once we get like which tool to execute and what inputs to send. So now that you realize like how can we make LLM tell like which tool to use and with what input, you can actually think of building the AI agent end to end as well. Like if you have seen last 2 videos, this will be like very clear to you. But also let's just add one small part here before building it end to end. There is this scratchpad thing that we want to add, where agent keeps track of what all tools have been called and what was the observation of those tools. So if it decides to use like one tool after the other, it should know like what were the tools that were called previously and what was the output for it. So that history will be saved in agent scratchpad. You can call this anything, it's just a name. And this is done like changing the prompt itself. So we use message placeholder. This was also discussed while we build Chatbot using LangChain. You can also refer to those videos to get a better understanding of LangChain. So basically we define the same system message. The query will go here, and all the scratchpad messages will be replaced here. Replaced with something like which tool was asked to be triggered and what was the observation of that tool. And if there are like multiple tools and observations, they'll all be like in one list and it will all be replaced here. Since we changed the prompt, let's redefine our chain. And now we can run the chain again. So let's run it on the same message. Oh, so now we'll have to give the scratchpad as well. For the first time, let's give agent scratchpad as empty. We have gotten the result. Let's just print the result to be sure. So again, it's asking us to use search product with this blue handbag query, which is correct. And since it's asking us to run the search product, let's just run this again. So we'll run it with search product and save the observations here. Great. So at this point, we have like the result, which is like LLM's result, which says like I want to use this tool, and the observation. So we actually ran that tool, and this is the observation for that tool. Now we'll have to put it in a format and append it to the agent scratchpad. So the way we do it is we use this format to OpenAI functions. This is again a LangChain's simple function. And the way we use it is, let's say we call format to OpenAI functions and we pass in the list. And in this list, we pass in the result, which is LLM asking us to use the tool, and the observation of that tool. So when we run this as format to AI, OpenAI functions, we get this AI message saying that, hey, this is the function call that we want to make. And if you see somewhere here, this is the function message. This is actual observation. So it just gives us the list of these two messages that we can add it to the scratchpad. So let's take this and put it through the scratchpad now. Let's do one thing, like let's try to search for blue handbag again, but this time we'll give it the scratchpad, basically give these two additional things that were already ran. So this was the tool call and this was the observation, and when we do this we get result 2, and now we can check result 2. So if you see here, we get agent finish now, saying that it doesn't want to actually use any tool, but since it has this context that, hey, if I call this tool, this is my observation, it's asking us like this is the finish and this is the return value with this as the output. So if you see like at a broad level, like these are the blue handbags that you might like, it's formatting in a certain way. Like we can actually key into these keys and then actually print it properly. So if we print the actual output, this is how it looks. So it just took the observation from the scratchpad. It's like, oh, I already have the results, let me just put it away, rather than trying to use another tool and so on. So it didn't call a tool, but it said it gave out this agent finish, and then this is the final response that we get. So I hope you're getting some idea now. Like we want to run a loop basically till we get agent finish, so that we get a response to return. Just like how we did in last two videos, there will be a loop till it wants to call the tools, and once it thinks like, hey, this is the end, I want to return the output, it can come out of the loop and return. So we'll write exactly something like that. So to implement the loop, let's say we'll do something like this. What we'll do is we'll start a infinite loop, and we'll keep calling the chain, and we'll keep appending to the agent scratchpad all the tool calls that were made. So basically we are appending these intermediate steps, and if you see, these intermediate steps will be the result and observation. Result will be tool calls. So if it is an instance of agent finish, and this agent finish we are importing from LangChain, but this is what it means. If it is an agent finish, then we'll just return the result. Else we know it's a tool call, so we'll extract out the result of the tool. This is known actions. Okay, so this is a dictionary that we'll have to define. Let's define it here. So known actions, I think you can relate to the last videos. So these are the 4 actions that we have, or the 4 functions that we have defined above. This is the string key, and this is the actual function that it maps to. That's it. That's all the known actions there are, like only 4 actions. So it will key in this known actions using result.tool. If result is a tool, we are here, otherwise we'll return. So which tool to call, we'll get it from known actions, and this tool will actually be a function now. So this returns a function, and we can do like something like tool.run, and we'll do result.input to send the input params as well, and then we'll get the observation. Now once we get the observation, we'll append it to these intermediate steps with result and observation, which will be converted to the OpenAI format, OpenAI functions format, and added to the agent scratchpad. And this agent scratchpad goes through the prompt. If you remember, we defined our chain here, this agent scratchpad. So it will have everything now. It will have the system message, the user query, and all the tools that are being used. So this tool was called this observation, this tool, this observation. So this will be filled like that with these messages: AI message asking for a tool, and function message showing the observation of those tools. Yeah, basically this is the loop. If it encounters agent finish, it will just return. It will just come out of the loop basically. So this is how like we can write this agent loop in LangChain as well. Now if we use this run agent, it would work, but since this is LangChain, let's add one more step of complexity, unnecessary complexity, so that we learn a little bit more about LangChain. So this is about runnable pass-through. So what we can do is instead of using this as is, we can actually take this step outside and put it in the chain. So what I mean is we'll rewrite this agent chain, and in the start we'll assign this agent scratchpad, which will come from intermediate steps. So this is an additional argument that we'll include from the intermediate steps. So intermediate steps will be sent when we invoke agent chain, and we'll keep appending to this agent scratchpad now, and agent scratchpad will be an additional arg that will be included and sent to the remainder of the chain. To make it a little more readable and simple, let me just replace chain with the actual things that we had. Yeah, chain can just be replaced with these three modules. So it's a runnable pass-through. Whatever input we get, take out the intermediate steps, format it to OpenAI functions, put it to agent scratchpad, and then send it to prompts. So the prompts, if you remember, it uses agent scratchpad. It will reuse that as it is. So now that we have defined this agent chain, we can rewrite this run agent loop in a better way. And the way we do it is like this. So if you see, intermediate steps is just intermediate steps now. Intermediate steps will just be a list. It won't be formatted. And then when we run it again, so it loops. And when we run the result again, we invoke the agent chain now. So it will, in the next run, it will take the intermediate steps, because this is a runnable pass-through. It will take the intermediate steps, convert it to functions, and add a agent scratchpad parameter while passing it through the next steps. So it works the same way. If you understand this, it's fine. You can go ahead, use this function, or else you can use this as well. So it's just one additional small step we got to learn about runnable pass-through as well. Remember, runnable pass-through.assign just assigns new variable before sending it to the next chain. So it will take the input, add agent scratchpad as the arg, and pass it through prompts, the subsequent components of the chain. So now that we finally have defined our loop, we can call it like this, and let's pass in the query with the same query. Let's not change the query for now, just to keep things a little simple. Let's run this and see what happens. So we have gotten our response. It has formatted and given all the response properly. That means it ran correctly. It ran in a loop. It might have called the tools, attached the observation, again appended it in the scratchpad, and then next time when we call this, it generated this proper formatted response like we saw above. We can also print out just a response and see, just to show you what we get. So we got agent finish, and this was the return value basically. It's kind of similar to what we did above, but this time we did it through a loop. So just to take you through the code like one more time, when we call run agent with this query, we come here, we have a query, and intermediate steps we start with a empty list, and then we start a loop. So first time when we call this chain, we are having like empty intermediate steps and only the user input. And this is the agent chain that it will go through. So it will take the intermediate steps, add it to the scratchpad. For now, a scratchpad is empty. And then when we send that to the prompt, it says like, I want to search for a blue handbag. It goes through the model, and maybe it decides to call a tool. So in fact, looking at the output, yes, it did ask us to call a tool. So it won't return here. It will actually call the tool, get the observation, and it will add to the intermediate steps. And now next time when we go through the loop, now intermediate steps contains the tool call and the actual observation of that tool. So now when we invoke this chain again with the same query and filled intermediate steps, now the intermediate steps are not empty. This goes through this chain again, and it formats and adds it to the scratchpad. It overwrites it. So scratchpad was empty before. Now it has two values, two messages. One is the tool call and one is the observation. That goes through the prompt. So if you go and check the prompt, it will replace those two messages in the prompt in the scratchpad here. So this is replaced with two messages, tool call and observation, and in user message we replace it with the actual user query, which is get the handbag, search handbag. So this kind of like result two, where we have input and scratchpad is those two messages with actual tool call and observation. And then when we again call this, maybe here it gave like agent finish because it has gotten the observations, and then it just formatted the observation in a proper way and gave this this result as output with a proper formatting and all, and that's what we printed. So this is how the loop works. Hope you understood it. Maybe refer to some LangChain docs with runnable path through and all if you want to learn more about it. Yeah, that's about how you can write your own loop using LangChain. There's an even simpler way to do it in LangChain. Basically, we don't have to write this loop ourselves. LangChain already has the implementation of this loop or slightly better version of this. Basically, there are more functionalities to it that you can do with some more parameters and all, and that is encapsulated in AgentExecutor class in LangChain. So let's import that and run it through AgentExecutor this time. We'll import AgentExecutor, and this is how we'll define our executor. We'll still pass in the agent chain, which takes in the intermediate steps and user input, and passes it through this chain. So this is the chain that it will take. It will take the list of tools that we have, and we can set verbose as true as well, so that we know like actually what is happening. So basically, like we could have added more logs here in this loop itself, but since we are using the AgentExecutor, it has functionality for all these things. So let's just go ahead and use AgentExecutor. So that's it. This is the one line that we wanted instead of this loop. And now this AgentExecutor is runnable, so we can invoke this with our input. So this is the query that we are going to give. Let's keep it same. So you see like verbose is true, so it will start giving out these logs. So invoking search product with this params, and this is the observation that it got. Yeah, maybe it went again and it reformatted this observation for us, and then it's like finished chain, and here is our actual final response that we have printed out here. So this response print response output, this is the actual print that got executed. This is all from AgentExecutor verbose logs, right? So this is how you can see like what exactly is happening inside the loop as well. So this works. And now if we send another message to our executor saying add first product 2 quantities to the cart. So anyways, is asking us like if we want to add something, if we liked something from these. Maybe let's ask it to add first product with 2 quantities, and let's see what happens. Okay, it's saying like I can't add anything to the cart without knowing which product. So what happened here? So basically it's a loop, and it's very independent runs. It doesn't have any history of the chat or the history of what is going on, right? So this AgentExecutor is just a loop, like how we had, and in the loop only thing that gets appended is the intermediate steps. And for every run, whenever we call this AgentExecutor, intermediate steps initialize again, so they're empty in a single run, right? So for this run, when we search for a product, intermediate steps started from empty, and again when we call this add product, it started from empty. So there's practically no history that is kept. Now to add history, it's again like very simple in LangChain. We can change the prompt a little so that it includes history. So we'll add like another placeholder here called chat history, where we'll place all the chat that goes on like previously. So previously, if I had asked it to search for some product and it returned some product, it will save the query and response here, right, in these messages. So these messages will be replaced by historical messages. Let's reinitialize our agent chain, just because we updated the prompt here with this chat history. And here we'll use another LangChain class called conversation buffer memory. And this is just a memory of chats. And here we'll give like the key will be chat history, and we'll keep the return message as true. So this is just a memory that we define. Yeah, it asks us like some migration. I think they are migrating to some LangGraph memory state and all, but let's just use conversation buffer memory for now. Once we have done all these things, we can just pass in memory as memory, which is conversation buffer memory that we have defined, which keys to chat history. And this chat history we have added in our prompt, where exactly the messages need to be replaced in the prompt. So this is how, like, this is the only change that is needed. And now we have agent executor with memory. So now if we run the same query that we had, let's just run the same query, search for blue handbags. Great, it returned the response, and this time we didn't particularly like print it properly, so that's why it's just the output that we get, like just the return value. And then we can do something like add first product two quantities to the cart. Let's see what happens now. Great, so it's calling add to cart now, and product ID is taken as this B0 D5. Let's just confirm if that is the first product. Maybe here it will have like, yeah, B0 D5 LJ LM4 4ml, whatever. Yeah, looks correct to me, with quantity 2, so that's correct. And then we have added it to the cart, and it's saying like I have added 2 of the fabulous. It's giving some name. If you need anything else, or you can check out. So it works, like basically the history part, the memory part works. We can also see the cart if you want. So it actually contains this product with quantity 2. So yeah, this is how you can build an AI agent using LangChain as well. You can talk to it and make it do stuff now. This is all good, but I really feel like you should go back and learn from the scratch how you build AI agents if you haven't already, rather than first learning how to do it through LangChain. It will be very confusing, but if you actually know it from scratch, and if you know how to do it using function calling, this will be a piece of cake for you. You'll just have to maybe look through like these small classes like conversation buffer memory, and maybe this agent executor, what exactly it does, and runnable pass through these things. So these are few LangChain specific things that are there, but overall the idea still remains the same. Ask LLM if you want to make a tool call. If it does, make the tool call and give it the observation, and keep looping this iterative process, tool observation till our LLM says enough, I have the answer now. That's the main idea for AI agents. So this wraps up. I want to acknowledge and give a big shout out to deeplearning.ai. That's where I have also learned a lot. You can also check it out if you want. Like it's amazing resource that we have for free. So yeah, thank you so much for watching. If you liked it, please do consider subscribing and liking the video. I'll put my LinkedIn down as well if you want to, if you feel like connecting. Thanks guys, bye.